Hi guys, today we're going to be doing for loops, which is a way of condensing code, or it can also be used to fade up and down analog write values. So I'm going to go over those two things today. We're going to start with the code condensing aspect of a for loop. So I've got an LED wired up to my Arduino on pin 13, and I want that LED to flash a certain number of times. So we're going to start by writing that in the way we normally would. So we're going to do in LED, and I've got it wired to pin 13, so we're going to put 13 there. Go down to the void setup, pin mode LED, and obviously it's an output because we're writing to it. And then down here in the void loop, we're going to do a number of digital writes. So we want it to flash 5 times. So this statement here is turning the LED on and off once. So if we were using normal code, to get it to flash on and off 5 times, we'd have to copy this 5 times. So 1, 2, 3, 4, 5. So this now would be the code we have to write if we wanted to flash our LED on and off 5 times. And then at the end, we're going to do a long delay of 5 seconds. So let's see what that looks like when we upload it to the Arduino.
So we can see that our LED is flashing 5 times, and then there's a 5-second delay. And then it will loop back to the start of the void loop and do it all over again.
This is a fairly long piece of code to do something very small. So we can actually condense this using a for loop. So we're going to start writing our for loop up here. So you start a for loop by saying for, and then you have brackets, and then you have the square brackets, and everything you want to do is contained within these square brackets. So anything you want to loop a certain amount of times, you put within here. So in this instance, we want to digital write the pin high and then low. So I'm going to copy and paste that in here. Just going to neaten it up a bit. And we can get rid of the other 4 copies and pastes of that code because we don't need that anymore, because as you'll see, our for loop is going to run this piece of code 5 times, which means it's the same as listing this code 5 times. So as you can see, it's saving a lot of space. So the for loop works on what's based inside these brackets.
So I've switched to pen and paper because it's a little bit easier to explain this if I can use different coloured pens. So we've got our for loop in our code written like that. Then we open our brackets and we have some code in here which I haven't gone over yet. That's what I'm about to go over. Then we close our brackets, we open our square brackets, and we close our square brackets down here. So whatever's in between this square bracket and this square bracket, so whatever we put here in our code, is what we're going to loop a certain amount of times. The code we put in here is specifying how many times we're running it. So in this instance, we've put the digital write of our LED high and then the digital write of our LED low, which would flash it once. And here we're going to write code to turn that into 5 flashes by looping the code 5 times. So first off, when you see for loops written normally, you will normally see the value or the character I. And so you don't have to use the character I. You can use whatever you want, as long as it's the same in each part of the for loop. So a for loop can be split into 3 parts, which we'll go over in a minute. So as long as this is the same in each 3 parts, it doesn't matter what you call it. It's just an algebraic character or word that's used to track where the for loop's at. So for example, if you've looped 2 times, we save that to the value I, which allows us to track how many times we've run it and how many times we've got left to run it. So that might make more sense when I explain it in the code. So I'm going to use the green pen to draw I, so we can sort of see that it's included in all 3 parts of the for loop. So let's start with the first part of the for loop. We're going to say I is equal to 0. And that there is the first part of the for loop. So all that's saying is we're starting the for loop at 0, which is fairly logical really. If you're going to start counting, you'd normally start at 0. There are some exceptions to that, which I'll go over later. Then we do the second part of the for loop is and by the way, we disconnect each part of the for loop from each other by these semicolons. So that's one part, that's the first part, and then here's the semicolon. Now this second part of the for loop here is a true or false statement. If what we say here is true, then we are going to run what's between these brackets. So i.e. we are going to turn our LED on and off in our case. If this statement is false, then we skip from the end of the start of the for loop to the end of the for loop, and we continue doing what we were doing, and we just ignore whatever's in here. So we're going to write a statement that says I is less than, and we want to run the code 5 times. So we're going to say 5 there, and then we're going to use our semicolon to end that middle section of our for loop. So what we're saying here is if the algebraic number I is less than 5, then we're going to run this code. Okay? And the last part of the statement is I plus plus, which just means every time we run the loop, we add 1. This means add 1. What it means is, if we run through this a few times, we start I equals 0. Is 0 less than 5? Yes, it is. So this statement's true, which means we're going to run the loop. Before we run the loop, we add 1 to the value of I. So now I is 1. We run the loop once. Is 1 less than 5? Yes, it is. So we add another 1. Now I is 2. We run the loop. Is 2 less than 5? Yes, it is. Add 1. Now 3. Is 3 less than 5? Yes, it is. Now add 1. 4. Is 4 less than 5? Yes, it is. Add 1. Now 5. We come back round. Is 5 less than 5? No, it's not. That statement's now false. We skip from here to here. We ignore the code in here. And then we just continue running the code below. What we've done is we've written a statement that allows us to loop however many times we specify. So the number here, if we changed it to 20, then this would loop 20 times. If we changed it to 3, it would loop 3 times.
So now we can skip back to our code and fill out our for loop in here. One thing I have to mention is we were using I as a kind of an algebraic tracking number, if you will. It's important that we set up at the top that I is a number. So int I means that we're telling the computer that I is an integer, which is what int stands for. If we didn't do this, then we'd get an error that said I was not declared in the scope. And the reason we'd get that is because the computer wouldn't know that I is a number. So when we try and use it in the for loop to track how many times we run the loop, it wouldn't know what I is. So that's why we have to write in I up the top. So now I've set that, we can start writing our for loop. So we say I equals 0 and then semicolon because we want to start at 0. Then we say if I is less than, and then we're going to say how many times we want the code to loop. So we want it to loop 5 times. So I'm going to say if I is less than 5, then semicolon, and then we're going to say I plus plus, which means add 1 to the value of I every time we loop. So now what's going to happen is, let's just neaten this up a bit. So what's going to happen is our code's going to run down here. We're going to come to our for loop. We're going to set I as 0. Is 0 less than 5? Yes, it is. So the statement's true, which means we're going to run this code. Before we run the code, we add 1 to the value of I. So now I is 1. We run the code. Is 1, so when I say we run the code, we turn the LED on and off. So we've turned the LED on and off once so far. Is 1 less than 5? Yes, it is. So now we add another 1 to the value of I. So now I is equal to 2. We run the loop again. Is 2 less than 5? Yes, it is. Add 1. So now I is 3. Loop again. Is 3 less than 5? Yes, it is. Add 1. Now it's 4. Run again. Is 4 less than 5? Add 1. Yes, it is. So add 1. Loop again. Is 5 less than 5? No, it's not. So now that statement is false. So we skip from here to here. We ignore the code in the middle, and we just continue to run our code, which in this case is just a 5-second delay. Then we get to the end of the for loop, end of the void loop, skip to the start of the void loop and run it again. So what we should see is exactly the same as we had before, where the LED turns on and off 5 times because we specified 5 here, and then there's a 5-second delay, and that should happen again and again because we're in the void loop. So let's upload that and see if we see the same thing as we did before with the really long code.
So I've actually slowed the delay down to 500 milliseconds in the for loop just so we can see it happening more clearly. So we've got 1, 2, 3, 4, 5 LED flashes, then a 5-second delay. Once the 5-second delay is over, we'll go back to the start of the void loop and we'll see our LED flash again 5 times. And that is thanks to our for loop, and because we've got I equals 5 here, we're going to loop 5 times. So if we change this number to, let's say, 10, and go up here and upload the code, then we should say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're going to have that 5-second delay. And there you go. So that's how you use a for loop to control how many times things loop in code. We can use that to greatly condense our code. So as you saw at the start, we had to list this 5 times, whereas now we've just got one line of code that's running this 10 times, which is much more efficient. Next up, we're going to use for loops and analog writes to try and create this fading LED effect. Don't forget, because we're using the pulse width modulation during the analog write, we have to connect our signal line for the LED up to one of the PWM pins, i.e. pins 3, 5, 6, 9, 10 or 11 on the Arduino Uno. So I've got my LED hooked up to ground and pin 11.
So the best way to do this is probably just to do it and talk you through it as I do it. So we're going to start by setting up the LED, which remember is wired to one of the PWM pins on the Arduino. So I've wired it to pin 11. I'm going to set up in the pin mode. The LED is an output because we're writing to it. And now we're in the void loop. So we're going to use two for loops, one to fade the LED to its brightest at 5 volts, and one to fade it from 5 volts back down to 0 volts, in other words off. So we're going to start by writing the for loop to fade it from off up to 5 volts. So we're going to say for, before we do this, sorry, don't forget, up the top we have to say in I, otherwise it's going to say I is not declared in this scope. So we're going to say for I equals 0, because we're going to start at 0. Then we're going to say if I is less than 255, and the reason we're saying 255 is because that is the max analog write value for an analog write, which you'll understand in a second, because in the square brackets of this for loop we're going to use an analog write to create a voltage that goes to the LED, which is what is effectively fading the brightness of the LED. So we're going to say 255 there, and then we're going to say I++. We're then going to close the for loop and open its square brackets. Inside the square brackets of the for loop, we're going to say, now in the last one we were doing digital write, in this one I'm going to do analog write. And then I'm going to say, we're going to analog write to the LED, and then now normally I'd put a number between 0 and 255. But in this case, we're going to write I. So it's going to replace I with whichever value it's currently saved I as in the for loop. So I'll run you through that and it will probably make more sense. Oh, we're also going to add a small delay here so it doesn't happen too quickly. So let's run through this and see how it works. So we start the for loop, I is equal to 0. Is 0 less than 255? Yes, it is. So now add 1 to the value of I. So now I is 1. Then we run the loop. So analog write, LED, and remember I is equal to 1 at the moment. So we're analog writing, it's the same as writing 1 there. So now we have the delay and we run back round. Is 1 less than 255? Yes it is. So we add 1. Now I is 2. We run the loop, so it's the same here as writing 2. We run the loop again. Is 2 less than 255? Yes it is. So we add 1. Now I is 3, and it's the same as writing 3 there. So you can see how this is going to affect our analog write, and effectively what it's doing is fading the value of analog write from 0 to 255 by putting the variable I in here. So if you don't quite understand that, maybe take a look back at my video I did on analog writes. But effectively all we're doing is passing the algebraic number we're using to track the for loop into an analog write. So it's a little bit of a clever thing to do, but it's really useful. and it allows us to fade analog right values. So we can do things like fade LED brightnesses, or we can turn motors on slowly instead of immediately on. So there's a lot of different things we can use it for, and it's quite useful. So now what this is doing is it's fading from 0 to the max analog right value, so to 5 volts, so it's turning the LED from all the way off to all the way on. Now we want to fade from all the way on back to all the way off, and this is one of the times where you wouldn't start the loop at 0. Because obviously if we start the loop at 0, then we're going to start by writing 0 volts, and if we want to fade from the max downwards, we're not going to start by writing 0. So let's start another for loop to fade back down again. So we're going to say for I equals, and here we're going to write the max value of an analog right, so that's 255, because we want to fade from the max brightness to the minimum brightness. So we're going to say end it there. And now in the second part of the for loop, the statement that has to be either true or false. If it's true, we run the loop. If it's false, we don't run the loop. We're going to say I is more than 0. So now if I is bigger than 0, we're going to run the loop. Now we're going to say I, and instead of saying plus plus like we normally would, we're going to say minus minus. And then we're going to close our for loop and then do exactly the same as we did before. We're going to open our square brackets, we're going to do an analog write to the LED, and we're going to write the value of I, semicolon to end the line of code, and then we're going to delay 20 milliseconds. So we're going to run through this second for loop and see how it's working. So we start at 255. Is 255 greater than 0? Yes, it is. So that statement there is true, which means we're going to run the for loop. Before we run the for loop, we take away 1 from the value of I. So minus minus means take away 1, same as plus plus means add 1. So now I is 254. So we're analog writing to the LED a value of 254. Then we loop back round. Is 254 more than 0? Yes, it is. Take away 1, now it's 253. Analog write to the LED a value of 253. Go again until eventually we get to 1, and then we go, is 1 more than 0? Yes, it is. Take away 1, so I is now equal to 0. We analog write to the LED a value of 0, which is basically 0 volts, so we're turning the LED off completely. We run back around once more. Is 0 more than 0? No, it's not. So that statement's now false, so we skip to the end of the for loop and then continue to run our code. So if we ran this code, we'd see the LED fade from all the way off to all the way on, and then from all the way on back to all the way off again.
It's a celebration.